and welcome back. And so we're on to the final day. There is a couple of questions over the weekend as ever. I've started to do that more commonly now, but the final question of this weekly set, and this is an end of paper question. So I'm not going to say much else. I'm going to say pause the video, give it a go. What is your answer? All right, so without reading your minds, I suspect you've come to one of two answers, and I'll discuss those when I get there. So as ever, nice little diagram's going to help me think about it. So there's my cube. Now, what is it saying doing? So equilateral triangles. Well, I can't use the side of a cube because there's no way of making an equilateral triangle because let's say my cube side is 1, while a diagonal is √2. So therefore they all have to be diagonals. So the only way I can think of making this generically is by picking one corner and then going to an opposite corner and an opposite corner again to make an equilateral triangle. So starting with the corner, I'm going to start with this corner here. How many ways are there of making an equilateral triangle? Well, I could do this route instead, couldn't I? So I could go across and down. So whereas in this first one I've gone, let's say, down and down for the sake of the argument, well, here I've gone straight across and down. The problem is how I make sure I'm not duplicating my numbers, because actually this one down here, this vertex down here, well, if I'm thinking about going down and down, well, I'll put down in quotes because what I mean is the opposite side of the cube. Well, that would be the triangle created. I can't double count my triangles. So actually, each vertex only has one way of drawing a triangle if I assume from that vertex I'm going to the opposite side. And again, I'm using the word down, but what I mean is the opposite side to create my triangles. In other words, I'm not going across the top, which I'm kind of considering to be the same side. So that means there's 8 vertices, which means there's at least 8 triangles. So it's really between 24 and 8. As discussed, I'm double or indeed triple counting if I count them 3 times. So therefore it's just 8. So the answer to today's question is going to be 8. A nice set of questions this week. And actually the ones I've got coming up over the weekend, I think are quite nice as well. And actually if anything slightly better, but I thought I'd go with these because they're from a similar paper. So as ever, like, subscribe. When we get the SMC paper back and when I can release it and talk about it, we'll go back to talking about those questions. But for now, I'd say much easier week relatively to what we've seen recently. Thanks all. Bye.